Today we're going to start a brand new topic, and we're going to be working with polynomials for a while. Now, before we get to polynomials, we're going to start with basically working with what's called one single term and how to multiply them. So first of all, let's talk about what that word means. A term is like one piece of an equation, one single piece. And I said, for my example, let's say 3x to the fourth. Now, a term can have multiplication, division, or exponent. So when you look at that, you might think, well, there's two things there. There's the 3, and then there's the x to the 4th. That's not two separate terms because they're being multiplied together, so it counts as one. What would make it two separate terms if there was any sort of addition or subtraction? So basically, anywhere in a problem where you see a plus or a minus, that's going to separate things into two different terms. So for example, like the one I just told you, 3x to the 4th, that's one term. But if I said 3 plus x to the 4th, that's two separate terms. The 3 is the first term, and the x to the 4th is the second term. So addition or subtraction will separate things into different terms, but multiplication won't. All right, so let's get a few more vocab words down. So let's go back to my example of 3x to the 4th. The 3 is called the coefficient. And basically a coefficient is any number that comes in front of any variable. It's the number part of the term. Now, in that case, x is the variable. The variable can be any letter. You could have y to the 4th or z to the 5th. You can have more than one variable in one question. And then the last part is the exponent. So when I have x to the 4th power, that number 4 is the exponent or the power. So basically our main focus for today is we're going to be taking two or more terms and multiplying them together. Now the first thing I want to mention to you guys is you are allowed to multiply any two terms you want, always. So when you're adding terms, we do something called combining like terms, and they have to be the same. That's not true with multiplying. You can multiply any terms you want, even if they have totally different variables, even if one of them looks big and messy and the other one looks small and clean. It doesn't matter, you can always multiply two terms. So what we're going to do is we're going to start with the number part. If you're multiplying terms, start with just the coefficients of each one and multiply them all up. Then, one by one, you're going to go through each variable and you're going to do the same thing. If there's two different x terms, multiply them together. If there's two different y parts, multiply them together. Any variable at all, multiply it together. Now, one of the tricks of exponents that you guys learned earlier on is that when you are multiplying things with variables, you add the exponents. So here's an example of that. Let's say I was doing 3x squared times 5x to the 5th power. So if you follow the two steps above, the first thing I do is say, let's just worry about the number part first. So I do 3 times 5, and I get 15. Then we do the x part. So for the second part of this question, I do x squared times x to the 5th. Now, here's what I was reminding you guys of, something you learned before. When you're multiplying x's, you add the exponents. So x squared times x to the 5th equals x to the 7th power. 2 plus 5 equals 7. And that's what I have here. 15x to the 7th for our final answer. And one thing I want to go over with you guys, just to remind you why that rule is, if you look at this problem right here where we have x squared times x to the 5th, what that means, the x squared really means x times x. That's what x squared means. And I'm going to multiply that times x to the 5th. Well, then what that means is x times x times x times x times x. So I have x squared is 2x's, times x to the 5th is 5x's. Basically, you're multiplying together 7x's and you get x to the 7th power. So that's where that rule comes from. what you want to do is remember the rule. If you're ever multiplying variables and they have exponents, the rule is all you got to do is add those exponents. Okay, so a couple little tricky things that happen in this type of question. Remember, if there's no coefficient showing, it's a 1. So like this example right here, if I have y squared times 12y to the third power, even though you don't see it, this is 1y squared times 12 to the third. So when you go to do this problem, we're going to do it the same way. I'm going to say, okay, well, first of all, what is 1 times 12? And that would be 12. And then for the second part of the question, I'm going to say, what is y squared times y cubed? And I'm going to add those exponents. 2 plus 3 is 5. So my final answer for that would be 12y to the 5th power. And I have that typed out also, but I wanted to show you working it out. So that was the same question twice in a row. I was just saying, if you see a y squared like that all by itself, there's a hidden 1 as the coefficient. Now that happens with exponents too. So if you have a term that has a variable but with no exponent, like just an x or just a y or just a z with no exponent on it, that means to the first power, and you want to use a 1 again. So here's an example like this. Now, the other thing I did in this example is I showed you we're actually multiplying 3 terms together, not 2. So that can happen. But I'm going to follow the same rules. I'm going to start with the numbers. So when I look at my coefficients, I have 9, 2, and 4. So the first part of this question, I'm going to do 9 times 2 times 4. And you can use a calculator or just multiply it in order. It basically comes out to 72. 9 times 2 is 18, and 18 times 4 is 72. Now for the second part, what I'm going to do is m times m cubed times m squared. But remember, this is the little tricky part, that m, even though you don't see it, it's actually m to the first power. So this m is m to the first power. So when you add the exponents, you're getting 1 plus 3 is 4, plus 2 more is 6. So your final answer is going to be 72m to the 6th power. Now, if you didn't remember to put that 1 in there, you might think, oh, there's nothing there, so I'm just going to do 2 plus 3, and you get m to the 5th power, and your answer would be off by a little bit. So remember, whether it's a coefficient or an exponent, if you don't see it there, it counts as a 1. All right, now the last little piece for today is sometimes our terms have more than one variable. We've been doing just x's, or like that last one, just m's. Well, what if we had a question that had x's and y's and z's, or p's and q's and r's, like a whole bunch of different variables mixed up? So what I said in the notes is do the same thing, just do each one separately. So let's do that. Let's do this question right here, which is an example of that. So what I'm going to do, we'll go one at a time. Let's start with the coefficients. First of all, I'm going to just put some parentheses here so you can really see what we're doing. All of this together is my first term. 4p squared q r cubed. Times, that's what the little dot means, and all of this together is my second term. So I'm really just multiplying 2 terms here. They're just a little bit bigger, more complicated than last time. So as I started a second ago, let's do the number part first. 4 times 2, that's easy. 4 times 2 is 8, so the first part of my answer is 8. Now let's go through each variable one at a time. The first variable is p. Now notice I have a p squared here. I actually don't have p in the second one. That means I have nothing to multiply p squared by, and that's just going to stay part of my answer. Okay, the third part is the q's. So I have a q, which remember, I'm going to put the little 1 here to remind myself this is q to the first power. And then here I have q to the 5th power. So I'm going to multiply that. Q to the first times q to the 5th. And I add those exponents. 1 plus 5 gives me 6. So I'm going to have q to the 6th power. And we'll wrap this question up by doing the r's. I have r to the 3rd times r to the 4th. and I'm going to add those exponents too. So I just get just a r. You don't have two r's in your answer when you multiply. You leave it with one r and you add the exponents. And for this one, 3 plus 4 is 7. So I'm going to have r to the 7th power. So that's my final answer. It's 8p squared q to the 6th r to the 7th power. And I color-coded it for the notes so you can really see each step. In green, that was the coefficients. I just multiplied the numbers. 4 times 2 is 8. That was probably the easiest part. Then in blue, I did the p's. And what I noticed is I'm not even multiplying. I had a p squared and nothing to multiply it to, so I just put the p squared in my answer. Then in red, I did the q's, and that was a little bit tricky because there was no exponent. I had to remember it was a 1. And then in purple, I did the r's, and that was just adding. 3 plus 4 is 7. So we did get our final answer. Same thing I had typed out, but I wanted you to see the steps and walk you through it, and I think it helps you to see it in colors too. But basically, this is our first step towards working with polynomials, which is our next major goal for the class. So make sure you really understand how to multiply terms, and you'll get some practice in the assignment today. All right, one last rule you guys are going to see is about raising a power to another power. And I wanted to remind you guys about that because it does show up in the assignment today. So basically, here's an example. For one example, I said x to the 3rd power raised to the 4th power. That's what it looks like. It's when you have something with an exponent in parentheses raised to another power, that's when you multiply the exponent. So when I have x to the 3rd and then I raise that to the 4th power, I do 3 times 4 is 12, and I get x to the 12th power. Or if you want to see another quick example here, let's say I had y to the 5th power. And then I put that in parentheses and I raise it to the 10th power. That would end up being y to the 50th power because I would do 5 times 10. And here's an example of that with a little bit more complex term in it. So let's say I had 5y squared and I raised that to the 3rd power. What I would do is I would kind of separate, and you can see what I did there. You can see the work. I took the 5 and I raised that to the 3rd power. Then I took the y squared and I raised that to the 3rd power. Now for the final answer, 5 to the 3rd power is 5 times 5 times 5, which comes out to 125. And y squared to the 6th, or y squared to the 3rd power, you use our trick, you multiply the exponents again. 2 times 3 is 6. So there's 3 different examples. We have the one with the x, the one with the y, and then the one with the 5y squared, where you have both a coefficient and a variable. And again, that's just something that shows up in the assignment. Our main goal for today is multiplying terms, but you will see this once or twice in the activity.